Okay, thanks everybody for attending. This is Preferred's semi-monthly webinar. This month we're doing cold weather fuel oil system design. I'm joined by Alex Canny, Preferred's representative in the Northeast for fuel oil and boiler systems. He works for ACS now, but he and I both do a lot of fuel oil system startups, and we've both done startups on cold weather fuel systems. So we got elected to do this webinar. Hello, Alex.
Hello. Looking forward to the comments that are coming in.
Ooh, nice already. Okay. This is us. I'm the VP of sales at Preferred. I do sales, and I kind of start up a lot of what I sell, and Alex is the same way. Alex's territory is kind of the northern New England, and I work pretty much all over the United States. So this is what we're going to talk about: cold weather diesel system design, retrofitting existing systems for cold weather, emergency responses, and then we've got some review. So going all the way back to the beginning, diesel fuel was sort of invented by Rudolf Diesel. He's the one that figured out how to refine crude oil into diesel and make a very repeatable fuel that could be used in boilers and engines. And ASTM D975 is the standard for number 2 diesel fuel. There's 7 grades of diesel fuel, and what a lot of people don't know is nowadays diesel fuel can be up to 5% biodiesel, so all the way up to B5, and they don't have to disclose that to you. So if you're buying diesel fuel and you don't want biodiesel in it, you need to tell the fuel company you don't want biodiesel in your fuel, because they can put up to 5% in and not even really disclose it to you. So just some definitions. The cloud point is the temperature at which wax begins to separate when oil is chilled to a low temperature. It's usually about 14 degrees for ultra low sulfur diesel, depending on the blend. There's another standard. There's the cold filter plugging point, CFPP method, is used to determine the low temperature operability of diesel fuel. It's usually around 10 degrees F for ultra low sulfur diesel. And we've got pictures here on the right of clogged strainers and clogged filter elements from diesel that's gelled, gotten below its cloud point.
For the most part, David, would you say that when we're looking at filters getting plugged like that, that's going to be on the generator end? I mean, other than polishing units, we really don't have filters that are that tight on the back end of most fuel systems.
Oh, for boilers?
Or for a generator application, right? I mean, we typically would have strainers on the transfer pump as opposed to filters.
Yeah, but I've seen strainers get clogged by gelled fuel as well. It just depends upon how small the holes are in the strainer.
Right. And
then ultra low sulfur diesel has been found to have a new property called cold soak, where if the oil isn't moving and the oil is subject to cold, it forms these crystals. And I was able to find a pretty good picture of these wax crystals that form an ultra low sulfur diesel. And it was first noticed in the Northeast in about 2007, and it occurs at temperatures below about 12 degrees F.
So these are crystals that tend to stay crystallized even after the temperature is elevated?
That's what I read.
Wow.
So it takes a lot of heat and a lot of mixing probably to get rid of these, because I think at that point the diesel has separated, and those crystals probably are just one of the components of diesel.
And that's going to affect things like lubricity and heat content going forward if they're not remixed into the fuel.
Yeah, so I think it's going to take some heat and some agitation to get those back into the fuel, because it's a different chemical property than the number 2 diesel composition you started with. So another big thing is ice formation in ultra low sulfur diesel, and I experienced this firsthand in 2021. So ultra low sulfur diesel at 30 degrees F, well above its cloud point, only holds about 35% of the water it holds at 75 degree F, which means if your diesel gets chilled from 75 F to 30 degrees F in cold weather, it's not going to be able to hold as much water as it did before, and the water is going to drop out and go to the bottom of the tank, and it can potentially freeze at the bottom of the tank, and that's where your suction pipes terminate, is at the bottom of the tank. That could be all water. So the water gets pushed out of the fuel in little droplets, and if the fuel's below 32 degrees F, the droplets freeze and start to agglomerate. Ice crystals in the fuel can look just like wax particles in plug strainers too. And then if the water drops out completely, the water at the bottom of the tanks can freeze suction lines. And I saw this in Dallas in 2021. We had that big cold front come through, and the first day of the cold front, the temperature stayed in the low 30s. And I had a customer call me saying that they couldn't move any fuel. And I started working through the normal troubleshooting, and everything seemed to be fine. And I asked him to pull the strainer baskets out and take a picture and send it to me. And what he sent me looked just like a gelled fuel, but the ambient temperature had not been really below, down to 18 degrees yet. We'd gotten below 32 at that point, but not all the way down. So I at first ruled out, gelling of the fuel because it just hadn't gotten cold enough yet. But the picture he sent me it looked just like gelled fuel. And it turns out it was ice crystals that had kind of agglomerated together and clogged up a basket strainer. And it looked just like fuel that was being gelled.
That's
now, eventually, I'm sorry, Alex, go ahead.
That's one of the reasons I think that we're we talk a lot in these sessions about water content in the fuel. And that's just one other reason. I had an experience talking to a site in Rhode Island where they had some fuel gelling issues, and the fuel company showed up with some buckets of fuel treatment to try to thin out the fuel. And it worked temporarily, but they had so much liquid water at the bottom of the tank that the liquid water actually pulled the treatment out of the fuel and inverted the tank, and the fuel gelled back up again in a matter of minutes. So, when we talk about water in the fuel, these are just a couple of other reasons why it can pose a lot of challenges.
There's basically three strategies for cold weather diesel performance. One is keep the diesel fuel warm. Keep it warm above the cloud point, or if there's going to be water in the fuel, it's got to stay warm above 32 degrees F. You can lower the cloud point with winter blends or additives. And then, like Alex was saying, it's important to keep the water out of the fuel, because if your fuel has a lot of water in it, then your lower temperature limit becomes 32, not the 14 to 18 that's normal for ultra low sulfur diesel to actually gel. And these are issues that we've worked with for years at Preferred. We've done hundreds of fuel systems in very cold climates like Maine, Vermont, New Hampshire, Minnesota, and the Chicago area. So these are problems already solved, and we're going to show you some of the ways that we do this, and you can pick which one will work best for your facility. So this is just a typical piping diagram. It's a little hard to read, but we've got a pump set in the center pulling out of an underground storage tank, and then pushing fuel up to an emergency generator inside of a building. And that whole assembly on the right is a big fuel polisher that removes the water, and this one adds a chemical agent to the fuel too. This diagram is a schematic that shows how we typically will pipe a fuel system for an emergency genset. And I wanted to show this slide and the next one so that you're familiar with how we typically pipe these systems, and then some of our cold weather strategies will make more sense. So this is typical of an above ground fuel schematic. It's very similar to the underground fuel schematic, with the exception that we're going to have an anti-siphon valve between the main tanks and the pump set. And the anti-siphon valve is another thing that's out in the air that can freeze up. So this animation kind of shows how the oil comes out of the main tank through a duplex pump set to a supply header. This time we're showing multiple day tanks. And then the day tanks are either going to have gravity overflow back to the main storage tank, or if gravity won't work because we're refilling or going back to an above ground storage tank, we'll typically put a return pump on the on each of the day tanks, so that we can do pumped return back to the main storage tank.
Also, David, on these, if I could just jump in on the return pump there, especially when we're talking about cold fuel, one of the things that I kind of had to learn in the field over the last 10 years of starting up systems, a lot of gravity returns that are relying just on gravity that don't have an active return pump are relying on just the natural gravity, natural head of that fuel to fall back. If we're talking about a system that has a lot of exposed piping or a system in cold weather, those systems that already struggle to quote unquote gravity return, when you have cold piping and now you add in varying viscosity of fuel, that's going to be even more of an issue. So it's one of the reasons that here in the Northeast especially, we really try to push, if at all possible, having a return pump to actively return that fuel back, whether it's a high level condition in that day tank or whether it's the fact that the fuel is just in bad condition, needs to be returned to the main tank for polishing or removal. That return pump can be even more critical in cold weather situations.
Yeah, we're going to see here in a slide or two where the return pump's actually part of our strategy for keeping fuel warm. So the first thing to consider if you have a new system is location of your tanks and your piping. If you can do underground tanks, the earth is not only going to insulate your underground tanks, but there's also a lot of thermal mass in all that earth that takes a long time to cool down. So underground tanks and underground piping kind of have their own insulation to them, and just a lot more thermal mass that resists being cooled off with intermittent cold weather.
Yeah, and if you're in a place like, the state of Maine or other places where it may be more difficult to get a permit to bury a tank below grade, insulated tanks are an option as well, and we can work with you on that sort of thing also.
So the picture here on the right is kind of an all outdoor generator and fuel system. And these are the most susceptible to cold weather. And what's most susceptible is that above ground piping, especially with single wall piping, because that piping is going to be up in the wind, and there is a wind chill effect when we're talking about cooling off piping, because in heavy wind, you're going to transfer heat or transfer cold much quicker than you would if it was dead calm. So it's the above ground piping, especially the overhead piping is in the wind, that's the first to gel up. So take that into consideration if you're planning on doing all outdoor gensets like this. It's also more difficult to work on a system like this in cold weather. I felt really bad for the people I was providing tech support to in 2021 when I was, telling them to check this, check this, check this to get their fuel system going. One of the guys told me, I'm going to go in my truck and warm up for a while, and then I'll get started on your list. Because we got down to -2. And, for us here in Texas, that's really cold.
Yeah, I think it's important when we're looking at an overall system design, there are certain items that can be placed outside in the weather and in certain temperature ranges, but keeping in mind that depending on the device, that person might have to be out there as well.
Yep, absolutely. Okay, so consider putting generators and day tanks indoors. This is the best protection from the elements. And NFPA allows you to do 2 660-gallon day tanks indoors before you have to go to a special fire-rated room. And indoor fuel oil equipment is much more common in the Northeast U.S. Than it is in the rest of the country, because the big cities in the Northeast just don't have any room outside for their diesel systems. Whereas, out west here where I work, it's very rare to have diesel inside of a building. Our gensets and our main storage tanks and our pump sets are usually all outside. Sometimes the gensets and the day tanks will be inside and the main tanks will be outside, but sometimes it's all outside because, in general, for most cases, it's best to have all this fuel outside the building rather than inside, but that works against you when you're trying to keep the fuel warm in cold ambience.
Also, that's a starting point here in the Northeast, especially. If for some reason, based on life safety runtime or just the size of the system, you need to have additional storage inside the building up at the generators, we can work with you and with the AHJ to get that approved, whether that's, a special case permitted, or we could go to a different UL design. With some hospitals with large amount of storage up at an upper level, we've gone to a UL 2085 on the tank, fire protected. So there are ways to accommodate that on a larger system. I'd also point out in this picture right here, you see off to the left there, we have some polishing units. It's important to remember that while we try to mitigate water in different areas of the system, obviously it's bad for the fuel, it gets worse with cold weather, keeping in mind that there are a few spots where we're intending water to accumulate, and that includes the reservoir in a polishing unit. So if that polishing unit is designed to pull water out of fuel, you want to take into consideration that there may be water in that reservoir in there. So that may dictate either adding a heater to that enclosure or having that in a space that's going to stay warm.
Okay, so another thing you can do, and Alex touched on this, is specify UL 2085 fire rated tanks. Fire rated tanks have their interstitial filled with insulation, and that insulation will help keep your tank warm in cold weather. And then it's a good idea to insulate above ground piping as well in cold places, just to cut down on the heat transfer in cold ambience.
One of the things I would definitely recommend when we're talking about insulating piping, I see a lot of designs where, maybe you have a certain amount of fuel stored in interior or below ground or something like that. And usually the discussion becomes insulating and heat tracing the containment piping. And I think that's a really good option as long as we understand what the goal is with insulating, and even with insulating and heat tracing piping. Our goal is really to maintain fuel at temperature. It's not to necessarily add BTUs to a tank or to even try to elevate the temperature that much. The amount of BTUs you can add with heat trace and with insulation is very limited. So what we want to make sure in our design is that the fuel that we're putting into that insulated piping is already at a spec temperature, and that we're not trying to either elevate the temperature of that fuel or trying to elevate the temperature of the fuel of the tank that's going into. We're really just maintaining it along that route.
So I put this graph in here because insulation works for a while, but insulation isn't going to work if you have a prolonged cold spell, because eventually that cold ambient's going to get in. Insulation will buy you time. If you have a cold night, it's not going to buy you 11 days like we had here in Dallas, really all of Texas, where we were below the cloud point of oil for 11 nights in a row. So bear that in mind. What are you trying to prepare for? If you're trying to prepare for a cold night, insulation helps a lot. If you're trying to prepare for a prolonged cold spell, or you're so far north that weather under 18 degrees is just normal for you in the winter, then insulation is just one of the things that you're going to need to do. We get asked to provide tank heaters a lot, and we don't usually supply them very often. We try and talk engineers out of tank heaters because these immersion heaters can provide BTUs to the oil, but they don't provide any circulation. So unless you've got circulating pumps in the tank or some way of circulating the fuel and heating it, immersion heaters like this are not very effective. And I've actually never seen them in the Southeast where I typically work. Alex, do you see these in the Northeast?
Where we tend to see these quite a bit is as a retrofit on a system like that maybe has a large belly tank, and they're not particularly effective at that because of the reason that you said. They don't provide any circulation. So sometimes you can get lucky and maybe there'll be a fitting that's close to a drop tube or something where they'll help to mitigate the issue. But as far as a systemic cold system, they're not going to be a solution. They're going to be maybe part of the solution. But again, like you said, we wouldn't necessarily start here when designing a system.
Okay, but more common in a small day tank or belly tank than a large main tank.
Usually, it's something that's tried along the way before, before another solution is found.
Okay. So this is a very old school trick called a stub heater. And the stub heater is either an electric heater or a steam coil heater that just heats up the oil around your suction pipe in a main oil tank. because the idea there is you don't need to keep all of the oil warm, you just need to keep the oil warm that you're going to pump. So this it cuts down on the kW that you consume or the steam you consume and just keeps some of the oil warm. And it's more effective than typical immersion heaters because it's not trying to heat the oil in the whole tank, just the oil that you're concerned with, the oil you're pumping out of the tank. We still supply these. This is a 50, 60-year-old method that we still use once in a while. Word about tank heaters. So a suction stub heater, our 2.5 kW version will heat about 48 gallons per hour of oil up to 40 degrees F. And 48 gallons per oil will supply a 600 kW generator. So you can see on the chart on the right, we offer a bunch of different sizes, and this just give you an idea of how many kW it's going to take to run a suction stub heater. And really, 2.5 kW is not a lot of electricity compared to some other methods that we're going to show you later. So we get asked a lot about heat tracing. And I found this picture on, this was a plant that was being built out in West Texas, where it can get very cold too. And heat tracing, this was during construction. You can see that the heat tracing cable is being held in there with strapping tape, and then it's going to be covered by insulation. It's really only effective with insulation. If you just left the heat tracing out there, the elements, most of the heat that you're adding to the system is going to go right into the air. But after you insulate that pipe, then that heat that you're putting into the pipe will actually get to the pipe and get to the fuel. And this is a good solution for keeping the most vulnerable part of your fuel system warm, the exposed overhead piping. But it's really just part of this complete breakfast. It'll keep your exposed piping warm. It won't add enough heat to a system to keep all of your fuel warm. But heat tracing is very common and does a good job with the most vulnerable part of your fuel system piping. So another way we do this is with a thermopump system. A thermopump system is basically just adding an electric oil heater to a duplex pump set. And the photo that you see on the right here shows a duplex pump set with one electric heater. I did a bunch of systems in Dallas after 2021 that had two heaters because the idea was we're going to have duplex pumps, we had to have duplex heaters. And we haven't had a cold spell like 2021 since then, but these have come on and have run a couple of winters in a row. There's really two ways these are controlled. There'll be an ambient temperature sensor that senses the air temperature. And when the air temperature drops below an adjustable set point, then it kicks on the lead pump. And if the oil going through the heater is colder than the set point on that heater, then the heater comes on and warms up that oil. And typically we will size the heaters for 40 degree F temperature difference between incoming and outgoing. And 40 degrees F is a lot. So it's a nice, comfortable margin.
Yeah, this is really the preferred quote unquote method that we see here in the Northeast. I mean, if I'm designing a system with an engineer, and the most effective piece of that system, if we're concerned about cold fuel in any area, whether it's piping, whether it's in a day tank, or whether it's in the main storage tank, is going to be to get a thermal pump in there. And the reason being is that this can address temperature issues any part of the system. The suction stub or immersion heater really is limited to its extreme location. But whether you're using the outdoor air temperature sensor or whether you're using an RTD in the main tank, or I mean, we can place an RTD really anywhere in the system if you want it up in a day tank and have this run. And the sequence of operations that you described, David, I think is really good because what that allows it to do is it allows it to number one, preempt. If we're using an outdoor air temperature sensor, we're not waiting for the fuel in that tank to get down to a certain temperature, but we already know that it's cold outside, right? And the second thing that does is it allows really two modes of operation. It allows a mode of operation where we're using maybe the thermal mass of the piping inside the building to gently raise the temperature of that fuel initially, and then as that cold soaks into the tank or the piping, we're bringing on that heater later on. So the heater does not necessarily kick on every time the pump runs. The heater's got its own local thermostat that'll kick in when the fuel actually gets cold. But sometimes all that's needed to take the edge off is to just circulate the fuel, maybe from the main tank through the building and then back, or whatever part of the system. And we can use control valves to really nail down what part of the system we're looking at. But overall, this is really the way to go, and the place that I start when I'm looking at a system that we're trying to make sure we're not going to have cold issues.
So I did a bunch of these in Dallas at data centers around DFW. There's a lot of corporate headquarters here and a lot of small data centers, and they wrote us some logic so that when the thermal pump was commanded to come on by cold ambient air temperature, it also commanded return pumps to come on, one belly tank at a time, and pump the belly tank down to the supply pump on level, which is 50% full. And then we would top off each day tank one at a time with fuel that came out of the thermal pump. So, and I think most of these systems had about 6 day tanks. So they would run through and pump cold oil out of the day tank one at a time, replace it with hot oil, and then throw a 3-way valve. And then we had an adjustable time where we could just circulate hot oil in and out of the main tank to put some hot oil in the main tank as well. And that system kept all the fuel warm throughout the whole, main tanks, piping, day tanks, everything.
I think that's a great idea. And one of the things that we tweaked here in the Northeast, because we've done it that way for a while, a lot of the newer designs though that we're doing with firms, you mentioned the 3-way valve on there. I think historically it was very common to use a 3-way valve to allow circulation back to the main tank rather than sending fuel up the riser to one or more day tanks. One of the modifications that we've made after meeting with different firms and looking at single points of failure is that we've modified that to a full circulation loop. So for multiple generators, it almost looks like a boiler loop, except instead of boilers, we have generators with flow control manifolds. And what we do in this case is that rather than having that diverter valve to send it back to the main tank, we're actually going to recirculate all the way up the riser and all the way back to the main tank. So again, looking at let's heat up all as much of the fuel as possible, right? And it also allows us to do flow proving on the main set so that if we do want to draw the level down on those tanks, we already know that we can pull fuel out of the main tank.
So these systems got tested last winter. It didn't get down to -2, but it got down to 14 degrees one day in Dallas last year. And I remember it well. It was the day of the Dallas Cowboys playoff game. And if you're a Cowboys fan, you understand they only get one playoff game a year maximum. And that was the day. And their thermal pump system came on when the ambient air temperature got cold, but they thought they were having an issue and they asked me to come out. It's only 15 minutes from my house. So I put on all my ski gear and went out and had to hit a reset button a couple of times. But the nice thing was this thermal pump system was running. It was 14 degrees outside and the job had a lot of overhead exposed piping. And my concern was if that oil got to, it gelled in the overhead piping, that can clog up the piping and we wouldn't even be able to move it with the thermal pump running. And it turns out the system was running and the oil was staying warm, and there's a thermometer on the inlet and the outlet thermometer is showing 52 degrees, which is really, really warm oil when it's 14 degrees outside. And just it gave me a lot of peace of mind knowing we're generating all this warm oil to keep, and we've probably had 100,000 gallons at this facility being kept warm with a thermal pump system, So this is the sizing of the thermal pumps. They come in sizes from a 101 to a 207, and the 101 and 207 refer to the size of the pumps. And then the heaters are sized for 40-degree difference in fuel temperature is what we try to get. And then the cool thing about it is, most of the year when it's warm, the heater stays off and it's like it's not even there. So the thing about diesel engines is they return, they pull fuel out of your fuel supply header, but then they return 2 to 3 times as much fuel as the engine consumes. And that returned oil is used for cooling the fuel rails on the diesel engine. So that oil comes back at 10 to 15 degrees higher than the supply temperature, depending on the size of the engine. And this warm oil will keep a day tank warm once the generator is running. So I had a plant in 2021 that was having a big emergency. They'd lost power. They could only get one of their gensets to come on, but that genset was running great, and they were having issues with their fuel system. And one of the things that they did was they noticed that on the day tank where the engine was running, they didn't have any snow on that day tank. That tank had gotten warm enough to melt all the snow off of it. And then they started manually turning on the return pump, and that circulated warm oil back to their main tank and helped them get their supply pumps going by warming up the fuel in the main tank. So in an emergency, if you can get a genset running, that genset is going to give you a source of warm oil that you can use to spread around through the system. It's going to have to be done manually. Our automatic controls aren't going to do this, but it's an option in an emergency. So we talked about this a couple of times. Water in your fuel really changes the lower temperature limit of your fuel from the normal cloud point of 14 to 18 degrees up to about 32 degrees. So it's really important to keep the water out of the fuel. And we make 5 sizes of fuel polishers that take the water out of the fuel and then take all the chunks out of the fuel too. The final filter element can be anything you want. I think our standard is a 10 mil filter, but that's a replaceable filter. We can put any size filter or any grade filter you want in it. And it's important when you run the suction line for the polisher that it go all the way down to the bottom of the tank. As close to the bottom of the tank as you're comfortable without danger of poking the tank during thermal expansion or something. Because the water and the sludge is heavier than the oil, so it's going to be at the very bottom of the tank. So the suction line for the polisher has to go to the bottom of the tank. And Alex mentioned this too. We can include an enclosure heater to keep that oil that we pull out of the tank, keep that water warm so it doesn't ice up your polisher as well.
David, we get 2 questions, I think, most frequently when we're talking about polishing. And I do like to use the term polisher rather than filter just because we're talking about water removal too, right? We're not just talking about particulate. But one of the questions we get is, hey, can I get a pump set filtration set? And like you mentioned there, this really should be on a separate recirculation line if at all possible. We don't want to be sending slugs of water up to a day tank. And we don't really want the filter plugging up to be able to stop us from running our generators. One of the other considerations to keep in mind is that, right, we have a strainer on here, we have a circulation pump, we have all these things. We don't necessarily want those in line in our critical path to keep the generators running.
I see that design every once in a while on drawings that we're asked to bid, where they'll show basically what we have inside this polisher between the supply pumps and day tanks or belly tanks. And we don't want that, because if you get a batch of bad fuel, or if your tank starts having a problem, if you clog up this filter, like Alex was saying, now you've cut off fuel to your gensets. I saw a design that had one of these Raycor filters and between the supply pumps and the day tanks, and then it had a bypass. And I guess the bypass was there in case the strainer ever got clogged. But if the strainer got clogged, the last thing you want to do is bypass that strainer, because then you're sending dirty oil directly to your day tank and then to your engine.
Right.
Now, the engine will have its own canister filter in it. So this isn't your last line of defense, but the canister filters inside the generator enclosure are usually pretty small, and if you have really bad fuel, they're gonna gunk up pretty quickly.
Yeah, once those plug up, then you're in real trouble. the second question that I often get all the time when I'm doing startup commissioning on these is how often should we set them up to run? And there's really no hard and fast rule. I think it comes down to the size of the tank, to the usage. We mentioned, in our controls that we have a 7-day setup where you can set it up to run for X number of hours, starting at a certain time on a certain day of the week. I have run into facilities that over filter their fuel where they run it 24/7. And you can actually see where you're going to age the fuel prematurely. But for most places, what I recommend is a periodic filtering for water content, because that's something that's going to be coming in every thermal cycle down through your vents. But really, after a delivery is when you're going to want to take a look at it as well. So it really depends on your delivery cycle, the amount of fuel that you've stored, and looking at also what your shifts are. Is this something where you're going to want to start and stop it within a single person's shift, or are they going to hand this off to somebody else? Is third shift going to have to address an alarm on it? So those are the sort of things that we need to look at when determining how often something like this should be run.
What I do is I set up polishers to only run during the day shift, because sometimes the night shift people are pretty busy or sketchy and don't have the level of training as day shift people. So I don't like moving fuel other than the day shift if it's voluntary polishing like this. And as far as how often to run your polisher, in the Southeast, it depends on your weather. It depends on how humid it is and what your temperature variations are. Because here in the Southeast, you wake up some mornings and it looks like it's rained, but it hasn't. It's just the ground cooled off overnight with very moist air, and it just condensed water all over your car and the road and everything else, making it look like it rained. And that's going to do the same thing inside your tanks. You should be doing a preventive maintenance at least once a year on your fuel system. And part of that preventive maintenance is taking a bottom sample of your main tanks. And if you have a polisher and you do a bottom sample in your tanks and you're still seeing water, then I would set the polisher up to run another day. If I've already got it going 8 hours on Monday, I'll set it up to go 8 hours on Tuesday, because water in the bottom of the tank indicates that we're not running the polisher enough.
And if you're not seeing that water coming out with your polishing system, that's probably going to need something you need to take a look at. In fact, I've actually had complaints in the past where the person's saying, I'm getting a water alarm on my filter, but there's no water. I had my tank tested and there's no liquid water in the bottom of my tank. And with a coalescing filter, we can actually pull that out of suspension. And so we had a situation where there was suspended water in the fuel being removed by our polishing system that they couldn't measure in the tank itself.
Well, that just means the polisher was doing his job and
Exactly.
not letting water accumulate at the bottom of the tank.
Right.
I don't know if I've ever had a polisher run too often, but you've seen that, Alex?
Yeah, I mean, it was a situation where they were just running it nearly continuously, and so what they ended up happening is that the fuel started to show a little bit of premature oxidation. Not the end of the world. Certainly, there was no particulate content, but this isn't something that needs to be run 24/7. This is something that would be run on a schedule, whether it's weekly or whatever, or based on deliveries. But yeah, that is obviously a very extreme case.
I had a customer that closed the inlet ball valve and the discharge ball valve on a polisher and then put the pump into hand and leave it that way for weeks until they burned out the pump.
Yeah, we don't recommend that.
If you do this long enough, you see just about everything. Okay, so the polishers are available from 180 gallons per hour to 1,200 gallons per hour. We have all the components in stock to make one, so the lead time is fairly short, 2 to 3 weeks. Most of them get standard programs. I never use the smallest two sizes. I think the PF503 is 600 gallons per hour, so it seems like the bigger fuel systems I see out west, we're always using 600, 900, or 1,200 gallons per hour. And we may develop a bigger polisher too to keep up with the Joneses. We've done larger polishers with larger pumps, but they become skid-mounted units like what you see in this picture. We can also do a chemical additive where it's got its own little metering pump and a tank full of additive, and we can recommend the additives to go into your fuel. there's a couple of different types of additives you can use.
If I could jump in on that, David, real quick on the additive side, I think metering in certain additives, whether stabilizers and things like that, I think could be a great idea. One thing that I see though here in the Northeast, and maybe it's just a regional thing where people like to get a hold of a can of something, like we do for our cars, like dry gas, right? Where I'm going to throw some of that in my tank, and that's gonna take care of my water problem in my gas tank in my car. A word of warning as far as those other additives can be seen as an end-all be-all for a diesel system. We've had experience in the past where many of those water mitigation additives that you buy a certain volume of and dump it in a tank, the problem with that is they don't actually turn water to fuel, right? It's not alchemy or magic. What they do is they tend to disperse it. And that's one thing if you're about to burn the fuel in an engine or especially a boiler right away, and you don't want a slug of water going in. But if you have a system like most systems here in the Northeast where you have a large amount of fuel stored over a long period of time, dispersing the water can be the worst thing you can do in a system, especially if you don't have anything like a polishing unit to then pull the water out, especially water that's suspended in the fuel, because you took a problem of fuel quality that really was at the bottom of the tank, right? The water was down at the bottom of the tank. Your sludge growth, your biological growth is going to be a function of that water at the bottom of the tank because it happens at the interstitial between the water and the fuel. And now that problem is happening all throughout the tank and maybe all throughout the system. And we've had systems where people have used water dispersing agents and then have had sludge grow in piping and valves. So just a word of caution on that. It's one thing if we're injecting stabilizers and things like that into the fuel after it's been polished, but some of these things that are marketed to just dump into the tank to take care of, whether it's cold fuel or water in the fuel, whatever it is, sometimes there's unintended consequences, and we see that. So having a dedicated system like this is really the place to start.
Okay, so we've talked about different ways of heating your fuel, different strategies. We've talked about the importance of keeping the water out of your fuel. There's another approach you can take entirely, and that's winter blend fuels. So what they'll typically do is blend number 1 ultra low sulfur diesel or kerosene with the number 2 diesel, and the cloud points can be reduced significantly. They're in the process of expanding on the McMurdo station in Antarctica, and we're doing the fuel system there. And when the inquiries first came in, I saw, McMurdo station, Antarctica, but no heaters. They specified fuel polishers, transfer pumps, day tanks, but no heaters in the system at all. So I got past the purchasing person and got to an engineer working on the system, and they said, no, we're good. They burn an Arctic blend down there that has a cloud point of minus 40 F, and even in Antarctica, they're able to keep the oil above minus 40 F without heaters. So, okay. You got to be careful though, because winter blend fuels are not typically available in warm regions. After 2021, I called to the major fuel distributors here in the DFW area. None of them offered a winter blend fuel. So for customers trying to take this route here in the South, where cold weather is not the norm, you may find your supplier doesn't have winter blend fuel. Up north, Minnesota, where Alex is at, winter blend fuel is pretty common, right?
It is. I would say though, for this to be a whole system approach, if you have a supplier that's adding anti-gelling November through March, keep in mind, if we're talking a mission critical or life safety facility, what is your delivery schedule, right? Are you getting deliveries in July, but you want your system obviously to run in January, right? So it's just going to take a lot more coordination with your fuel supplier. And that's one thing that we really can't control at the design phase. But if it's a facility, you really got to have that conversation with your fuel supplier to say, hey, I may be getting a delivery in August, but these are the considerations that I need to take year round. So it's just an extra layer of coordination.
Then if you're engineering a fuel system for like a greenfield facility, you should ask the question, are winter blends available? Because if the customer is comfortable with the winter blend and doesn't mind the hassle of a winter blend, then it's very economical compared to, you know, adding stuff to your fuel system. But bear in mind, like Alex said, emergency diesel gensets, data centers, they buy fuel and they hold on to that fuel sometimes for months or years before they actually burn it.
And another thing to keep in mind too, if you're waiting in line to get fuel in a situation where, you know, maybe you don't have a 72-hour outage, but you have a short outage or limited delivery schedule, you may be waiting in line for a winter blend, where if you have a system that can take something standard, it might open up some options in an emergency situation. So
yeah, during 2021, I got a call from a plant that I actually helped get them going on oil before the cold weather hit, because all the dual fuel plants in the DFW area were notified that on Saturday at noon they're going to have their natural gas cut off. They had to go to diesel. So I helped get their 2 water tube boilers going on diesel fuel. The next morning, I get a call from the plant manager, and he says, "I've only got like 18 hours of fuel left here. I can't get a delivery of fuel. I've called everybody. You know, do you have a super secret fuel supplier only known to boiler technicians that can get me a fuel delivery?" No, I don't know anybody like that. And he didn't know that, you know, you can't use the top 10 or bottom 10% really of your main storage tank. So he didn't have 18 hours of fuel left. He had about 15 hours of fuel left. So that was a rude awakening for that plant. There are some additives that we recommend. We sell an oil dehydrator. Like Alex says, you got to be careful how you use it. We sell something called free flow that goes to the bottom of the tanks and disperses the ice to get the oil moving again. We sell a tank protector that just lowers the cloud point of the fuel, and it's available in quarts, gallons, and 55-gallon drums. And you've got to read the directions on these, because some, you know, it's like mixing for your chainsaw or your weed whacker. Some of these are 20 to 1, some are 30 to 1, some are 50 to 1. And when you've got a big storage tank out there and the additive says you've got to mix 30 to 1, that's a lot of additive. So bear that in mind. So we've talked mostly about gensets so far. I want to talk a little bit about boilers. A lot of boiler customers are on interruptible gas service, and they'll be notified they've got to switch over to oil in cold weather, so we can save the gas for the homes that can't switch over. And here, you know, here in the southeast, nobody has oil fired anything in their homes. All of our heat is either gas or electric. So the number one thing I run into when these plants switch over to oil is the operators don't have enough experience firing oil, and they don't really know how to do it. So the VA hospitals do a good job of this. They require all their boilers to be run for 8 hours a month on fuel oil. So that's all their boilers. Typically, there's 3 in a plant, and then the smart plant managers will run fuel in the day shift 1 month, then swing shift, and then night shift, and make sure all the operators get trained to know how to fire on oil. And in fact, the reason I got called out to help get some oil burners lit was somebody had replaced a servo and on an oil valve. And when you replace the servo, you've got to kind of recommission and re-verify your points. And the technician didn't do that because they weren't firing oil. So they tried to switch over to oil, and the system wouldn't run because their oil points hadn't been verified. So I had to go help work them through that. So when you get a tune-up on your boilers, make sure they tune up setting data. You want to make sure that they set it up the way you want it. You want to make sure you're not smoking at any of the load points. And then you want that setting data available to your operators so that they know what normal oil operation looks like. Bear in mind that replacing a servo or control system components can require re-verification on oil. So literally anytime you have work done on your boilers, it's good to go back on oil and and make sure that nothing on the oil firing was affected. Something else I experienced was sticky oil safety shutoff valves. If you don't use these safety shutoffs after a while, the valves will stick and they won't open. And the Cadillac in oil safety shutoff valves is the Maxon valves, but they're susceptible to this. I've had Maxon valves. They get the little gate in there all gummed up with oil when it's not being used, and that kind of glues the oil valve shut, and the actuator can't overcome that glue. So it's important to exercise your oil valves every once in a while by running the burner on oil a little bit. At least light it off and exercise the valves a little bit. And then our technicians do a lot of preventive maintenance on fuel systems. Here in the Southeast, where we're concerned about hurricanes, we do most of our fuel system PMs in May and June, right before hurricane season. Alex, where you're at, it's more in the fall, correct?
Yeah, it depends. If it's more of a boiler plant or a generator application, definitely recommend PM service though, even if it's a generator application. I think a lot of people assume the generator rep is looking at the fuel system, and that's just not the case. You're going to want to have a dedicated PM set up for that, and we can help put together a PM checklist or whatever it is you need for documentation, but it's really important.
Hurricanes are our biggest concern here in the Southeast, but I was in Prince Edward Island 2 weeks ago, and they got hit by a hurricane a few years ago. It was a Category 3 hurricane all the way up north of Maine at Prince Edward Island. It's amazing. I don't know how a hurricane could get that far north with so much cold water in between. Okay, that's all we have. We are going to hang on now. Alex and I will be available. If you have questions, you can email them to either the email addresses here, or you can put them in the chat box, and Alex and I will stick around and answer all of your questions.
Looking forward to it.
All right, Alex, thanks for joining me today.
All right, thank you. All right, thank you to everybody who was able to join us for that webinar. We're going to be taking a look at some of the questions that came in during the presentation and answering those to the best of our ability in order. If you have any questions, please submit them right now. And if you have any follow-up questions, of course, our contact info is on the presentation, on the website as well. And feel free to give us a call or send us an email if you have any questions or projects that you're looking for some assistance on. All right, taking a look at the questions that we have right here. Number one, how much insulation is typical for a bulk storage tank? So the typical recommendation that I'll make if we're looking at just a standard insulated main tank above ground, I'll usually do 2 inches of mineral wool, and then on the outside of that, we do aluminum cladding with silicone sealing. That's going to be generally the spec that I'll recommend. And obviously, depending on the size of the tank, other details of the system, we may adjust it from there. But that's typically recommend is 2 inches of mineral wool, and then some sort of a cladding on the outside of that. And keep in mind that's outside of the UL 142, right? We talked earlier about some fire rated tanks and things like that. Any additional insulation would actually go on the outside of the secondary. So keep that in mind when planning footprints and spacing and stuff like that. Let me go ahead and give out the email addresses where you can reach myself directly, or if you want to reach out to also, depending on where you are in the country, if you go to our website, they'll direct you to the different regions for local support. My email address is acanney, ACANNEY, at acs-ny.com. So feel free to send in any questions either to the chat in the webinar right now or to my email, and I will follow up with you on those as well. Next question. What alarms or statuses should be reported to the building management system or building automation system for a heating system like this? That's a great question. one of the things that we want to be careful of when we're looking at a heating system that we've run into in the past is sometimes you have over-reporting, where you have a system where you're reporting every time the heater turns on or something like that. Keep in mind that we want to differentiate between status points and alarms, right? We don't want to necessarily ring a bell every time the system comes on because it may just be recycling fuel and maintaining temperature in the main tank, which is not an alarm, that's just normal operation, right? Just like we wouldn't send an alarm necessarily every time the pumps turn on if they're just replenishing a day tank, for instance, or responding to a call for fuel. The things that we want to alarm would be if we're completely out of spec on temperature, high temperature, low temperature, that sort of thing, and that's going to depend on the application and depend on the specific system. But yeah, we'd want to report probably statuses when the circulation pump is running, maybe a status for when the heater is on, and then if we're out of spec temperature on that. All right, next question. If a thermal pump is used, do we still need heat trace? That's a great question. We talked about both items in there earlier. It really depends on the amount of exposed piping. So keeping in mind some of the basics we talked about, right? Heat trace is not used to add BTUs to a system. It's used to maintain temperature across the piping run, whereas a thermal pump is used to add a certain amount of BTUs into the system as a whole, whether it's circulating to a main tank or whether it's circulating to, sending fuel up to a day tank and heating the fuel that's being sent. So again, keep in mind kind of the relative functions there, right? The thermal pump is designed to add BTUs to either a tank that's gotten cold, to preempt cold weather via air sensor, or to heat fuel as it's being sent up to a day tank, whereas heat trace on the piping is used to maintain temperature in a longer run of piping. So if there's very little exposed piping, then it's possible that maybe just insulation would be appropriate, right? If we just have 20 feet or so of exposed piping on a roof or something like that, maybe we don't need to go to heat trace, maybe we just insulate. As the run gets longer, obviously heat trace is going to be more and more important. And also as a reminder, we talked a little bit about the sequence of operation earlier in the presentation for the thermal pump, that we have the option to circulate the oil before the heater actually comes on. So in those kind of shoulder months or areas where we don't need to add a ton of heat to the oil, having that set up to circulate the fuel is also an option. Just use the thermal mass from the piping that's in the building that's already up to temperature. All right, let's see if we have any more questions here. If an owner doesn't want to purchase a polishing skid, would you recommend a sequence for simply circulating the fuel using the system pumps that are already part of their system? Generally speaking, if we're talking about diesel here or number two, circulation is going to provide really limited advantages. If the drop tubes are set up where they should be in the main tank, you may really just be circulating that diesel with itself. You have to kind of step back and ask some big picture questions. Am I trying to mix the fuel? Am I trying to mix the water with the fuel? So if the step of purchasing a permanent polisher is out of the question, really I would, rather than trying to circulate the fuel as an objective in and of itself, I would recommend something along the lines of spending that time testing the fuel, getting some inexpensive water indicating paste and checking the bottom of the tank, getting some samples and having those analyzed. So I think the time would be better spent having the fuel analyzed to see if a problem is developing rather than just circulation. I think circulation can be helpful for scenarios where maybe there's a priming issue, keeping the system primed, making sure periodically that it can operate correctly. But as far as fuel quality, I wouldn't look at just circulation as a primary fix for that. I think really fuel testing and if you have to have something, have a third-party company come in at some point and maybe polish the fuel in place, that's an option as well if you don't have a standalone filtration unit for that system. Excellent. Well, again, thank you to everybody for your time. Thank you to the 18 or so folks who stuck it out all the way to the end. We really appreciate your time, and we'd really like to work with you on any projects that you have, whether it's boiler plant, fueling, mission critical, generator applications. There's a lot that's changed in the last few years, especially here in the Northeast where I'm located, and whether it's cold issues, whether it's fuel overheating, that can also be an issue, or whether it's just general fuel quality. Those are the sort of questions that I think are going to become more important. The more that we see these biofuel blends, the more that the green initiatives and things like that go forward. So now's the time to have these conversations. And again, feel free to give us a call. Office number there is on the screen, and my email address, acanny@acs-ny.com. That's ACANNEY at acs-ny.com. All right. Thank you, everybody.